others can trickle in when they can. And let's get going. Today, we're going to present just a quick overview of the SunWize Power and Battery Power Ready Express systems, which are intended to be kind of on the smaller side of the scale for solar arrays and battery banks, but it's a quick and handy way to do systems. And presenting with me is Errol Rankin. He'll pop in and out, and he will be watching your questions as you type those in, and we can interject those as needed or wait towards the end. So a wee bit about SunWize Power and Battery. We've been doing off-grid design of systems for over 20 years and literally have installations all over the world. And a lot of those we've seen, have been lasting that great long while with a few battery changes in between. And the Power Ready Express is just one of the range of systems that we create for standalone systems, hybrid systems with a backup source of batteries or generator or whatnot, and then also just straight battery backup systems to serve loads when the utility fails. The SunWize Connect website also has a lot of good information on components and pricing and ordering and all that kind of good stuff. So it's a good resource to have as well. We are located in many offices across the country with our headquarters in Oregon, along with engineering and R&D and some manufacturing and sales guys, of course. Our other main facility is in New York with manufacturing there as well, with engineering and sales offices sprinkled across the country. As I said, we do a wide range of systems, more than the Power Ready Express that we'll talk about today, but backup systems and along with component sales as well. So you can get just some of the components of a system and to make it fit your needs. More on the more severe engineering side of it, that's typically for larger systems. The Power Ready Express are fairly well self-contained and fairly simple to specify, size, and install. But we get into more complex systems that require documentation, technical writing, installation supervision for larger systems that we can go out and help you install if need be. And we're always around for troubleshooting and keeping the systems up and going and replacement parts. This is just a wide range of the climates and locations that we have our systems in. And I've done this now 23 years, and some of the early systems that I built are still up and going, and I pass them along the freeway. So with the right selection of parts and a periodic battery or controller change out, you can keep these things going for a great long while. The solar panels, as we mostly know, are kind of fairly well built and listen quite a bit, or last quite a while. So today on the Power Ready Express systems, we'll just give an introduction to those, some of the general features and how it's different from our legacy Power Ready systems, which are still available. We will cover the control panels and the different components that make up the system, along with some of our new accessory panels, and design guide overview. There's a lot of good information on the Power Ready Express, which is the PRE that we keep typing up here on the screen. And that can be found on our main website and also on our SunWize Connect catalog site as well. So what is the Power Ready Express? At the heart of our Power Ready Express systems is your choice of a pre-wired solar control panel that can be matched to the needed battery, enclosure, solar array, and mount. This flexibility allows us to serve the needs of the system with standard products that really allow the orders to flow right to the shipping department and bypass the custom engineering path to save you both time and money. it's the same components that we use on the Power Ready systems, which can be very customized, including, installation of customers or end users gear into the enclosure and pre-wired. And then it's just a matter of, it's all the same components, and it's a mix and match of what's needed for a specific system. And as I said there, and then we can also augment the control panels along with the accessory panels that we'll show in a bit to give a wider range of applications that the Power Ready Express can serve. The systems on the solar array side typically are between 10 and 1200 watts of solar with up to a 40 amp charge controller and battery banks up to 1000 amp hours. Most of the systems are 12 and 24 volts with an optional 48 volt for some systems, along with AC from a small inverter to serve small AC loads, and also converters to get 12 or 24 volts out of a system as well. So there's the building blocks of a Power Ready Express system. As I mentioned, the mix of solar modules and ranging from 5 watts to 300 watts in size for each solar panel, and mix and match to get the array needed to serve the load. The solar mounts can be side of pole mount, as shown here, top of pole or ground mount, or even a skid mount system as well. There's a wide range of charge controllers that can be fitted with different features and options. And then batteries, we have several lines of batteries to choose from. And all of that goes into one of our battery enclosures that we've been designing and building for nearly 20 years. And we have a lot of flexibility in this system to allow the choice of a battery enclosure that can also serve as the enclosure for your gear as well. What's a standard Power Ready Express system? With the flexibility that we have within the Power Ready Express line, we can offer a very wide range of battery choices, battery capacities, and solar array sizes, such that the list, if we created every combination, would be about a mile long. So what we've done on the standard ones is pick and choose and get a good sampling of what a range of systems is. And this sheet here shows 24 volt systems ranging from 10 to 1200 watts. And this will, based on your sun zone, this will cover loads from, part of an amp hour a day all the way up to 155 amp hours a day. And we'll get into sizing here at the end of the presentation. So the heart, as I said earlier, of the Power Ready Express system is the fully assembled, pre-wired and tested solar control panel with both a wide range of the standard Morningstar lines, which have been industry standard for a great long while, along with the Focus solar controllers that have been made in Germany, made from a German company for about 20 years, and are fairly new to the United States. These controllers are good ruggedized units, along with a lot of them with Class 1, Division 2 rated for oil and gas work, and different options. So they're between these two, you can serve quite a wide range of applications. The control panels, as you see, are all pre-wired and built and can bolt into most of our battery enclosures, so that we may even ship the control panels separately from the rest of the system, and it's just simply 4 nuts to attach it inside the enclosure. And the battery leads are included, so it's a quick and easy way to install the system. The SunSaver and ProStar line of the Morningstars range from 6 to 40 amps, and this slide shows that the new generation of ProStars actually now include a lighting feature, so that you can use the ProStar line and program it to run light at night. And then the fairly new ProStar MPPT style will allow a higher voltage solar array to feed a 12 or 24 volt battery bank. And this allows the use of the 60 and 72 cell, typically grid-tied panels, to be used to properly charge a 12 or 24 volt battery bank. And these feature a lot of features: lighting controls, data logging, and web-based monitoring as well. And then at this point we have a few of the Focus controllers. The smaller 10 and 20 amp versions are very handy because the same controller is both 12 and 24 volts. It's auto selects, so it's fewer parts to stock, and it's a handier small unit, and it's very economical, even compared to the industry standard Morningstar. And the Dingo is another one, and it also offers 48 volts, and that's where we primarily use that one. Here's the advantages of the PowerReady Express system compared to our standard PowerReady system. The names are very similar, and the Express really gives away the difference. It's the same components, and what we've really done is reduced both the cost and also the lead time compared to PowerReady systems by making and stocking the solar control panels. All the PowerReady Express systems also include a quick start guide to show how to connect the batteries and controls and solar arrays so that you can get up and running quickly. And most of the stocked PowerReady Express systems do ship within 1 or 2 days of the order. And if we don't have the specific control panel in stock, the lead time is generally only a week or so. So that's still a great reduction in lead time over the custom PowerReady systems. So we can choose based on the need what charge controller it is, based on solar array, based on voltage, based on if it needs data logging or a meter, or if it's for a lighting system. And since we have these more standardized systems to cover really 70 or 80% of the needs, then we can really reduce the lead time of pushing it through in engineering and making a custom product out of it. So and it also saves a lot of time, and it saves a lot of costs for the end user as well. So what we do on the systems is we have low voltage disconnect on most of the charge controllers except for the teeny tiny ones. And that just means that there's an extra layer of safety in there to prevent the batteries from going flat in case the load runs out of control and is taking more juice out of the battery than the solar can produce. They're all temperature compensated, which is a critical feature in off-grid applications where the temperature certainly varies away from the standard 77 degrees. Because in cold temperatures you need to bump up the voltage charge a wee bit to deal with the batteries working slower in cold temperatures, and also in hot temperatures it backs off a little bit so it doesn't overcharge the batteries. The enclosures that we use are all NEMA 3R rated, and most are powder coated white to give a nice good appearance and also to reduce heat gain a little bit. And also on all the solar control panels that we use, we also have circuit breakers on all 3 lines of the array, the battery to load and load lines. And that really does a few things. One of it is it's a safer approach, but the other part of it is for maintenance and troubleshooting that you can turn off the solar and isolate the battery as well. And this is just an example of a system that I placed into our warehouse staff and didn't really even tell them I was timing it, but from start to finish, it was about 4 hours to do all the paperwork on our side of it, pack it up and crate it up, and I'm sure they even took lunch in there as well. So with this approach of the standardized control panels that are stocked, we really can put together a system quickly and get it back out into the field so that you can finish your project. This is just how we name the Power Ready Express systems, with how much array, what voltage, battery capacity, along with the options for the enclosure, structure, and options. So there's not quite as many options with the Power Ready Express line, just simply because we've standardized the control side of it. But we still allow wide range of the enclosure options to be chosen based on the need for the system or the desires of the customer, and along with support structures for side of pole mount, ground mount, top of pole mount, or even a skid mount. So this is the standard configuration, as I mentioned, with circuit breakers and a load block with a load breaker as well. An example of a long part number. But basically it's a 300 watt system, 12 volts, 216 amp hours. So if you do require something that we don't serve via the Power Ready Express line, or we can't serve with one of the accessory panels that I'll show here in a second, we can still do it through our standard Power Ready systems that are more designed as custom applications so that we can meet any needs that are needed. So we've been building these for 20 years, so we can do quite a few different things. So some general characteristics. So wind speed, 110 mile an hour is typical for the mounts. And the battery capacity up to 1,000 amp hours, 1,200 watts. So just overall specifications on just the overall Power Ready Express line. Typically 12 and 24 volts, can do 48, and array size up to around 1,200 watts, and a wide choice of batteries. The batteries that we choose really are designed for either 50 or 80% depth of discharge and 500 cycles. So we like to do batteries that can give you a longer life out of them. And also systems are sized to IEEE specs that we'll get to here in a second. So as part of the installation manual, we have a quick start guide to help wire the solar array, along with properly putting together the battery bank and then making all the connections in the centralized hub of the solar control panel. And we're sized to IEEE, which here the cryptic note of ALR simply means that we have an array to load ratio of at least 20% higher than the array is expected to produce in that sun zone. And that's just a matter of a safety factor is needed just because we're dealing in the real world, and the solar data that we have over the long term is still an average for worst case. So some some Decembers are better than others. So we need to build a safety factor in there. And then also we've seen the trend and wholeheartedly support it, where the array to load ratio, the safety factor, has increased quite a bit here in those last couple of years, simply because the cost of the solar panels has plummeted, such that in many cases the solar panel can be one of the least expensive items in a system. And as you have a higher safety factor, or array to load ratio of 1.5, then we can treat the batteries better, and also get a longer life out of those, as you're not hitting them as hard on a daily basis. And also part of the IEEE spec is also a battery autonomy of 5 days. And that's where a lot of other folks really cut corners and do 2.5 or 3 days. And in an extended cloudy period or a long weather event, the batteries can go flat. And if you don't have a well-sized solar array, then it's really difficult for that battery to get refilled. The solar panels that we choose from are both what's called Class 1 Division 2 rated, and that's primarily for the folks in the oil and gas fields, rating for those. 12-volt panels are typically up to about 150 watts in size each. 24-volt panels can go up to about the 300-watt size each, or 315. So, and then we just put those together as needed to make 12, 24, or 48-volt systems. Batteries that we use are East Penn Deca, or MK. Makes great gel batteries with a long life. We've been using those for over 15 years, and there's some batteries that are still chugging along after 10 or 12, so it's a good long-lived battery. Concord is an AGM, absorbed glass mat sealed battery, with lots of fans out there and a long life, along with some other brands, and universal for budget-minded projects. The control panels, again, are Focus or Morningstar, and a wide range of controllers to cover the needs of the project. Wide range of mounts as well. So it's, like I said, can be even too many options, but we can chat with you and see what's needed for the system. The vast majority of systems of this range are side-of-pole mount, with 1 or 2 or 3 or 4 panels on a side-of-pole, and with the battery enclosure either pole mounted or chest style mounted right under that. So that's most common application, along with the option for some small skids as well. The enclosures are, as I mentioned, mostly white powder coated and vented, and pole mounted or small chest styles as well. So here's options for some of the smaller non-powder coated enclosures to hold up to 4 of the Group 31 batteries. And then this is by far the most common ones, are our F series that hold from 1 to 4 of the Group 31s, or other combinations of smaller batteries, along with space on the back panel for the controls, and the side panel mounting for the accessory panels as well. So at this point, if you have any questions, feel free to type those in, and Errol will be watching those. And we're also coming out with a new line of enclosures as well, to have a little bit different sizes. This is one that holds a single larger 8D size battery, so that's 265 amp hours in there, along with space for controls and a side panel. Oh, sorry, here we're little difficulties here. And then chest style is 2 to 8 batteries, along with some space in there for different combinations with control panels. A little bit more of a close-up of one of the newer Morningstar MPPT style ProStar controllers with a meter and buttons and whatnot, and input, output, load breakers, all pre-wired, factory tested, and then with flying leads to connect to the battery. So they simply just bolt into the enclosure with the 4 mounting holes. So the solar control panels with the Morningstar will give you the widest range of solar array possible. So on the 12-volt output, it'll be 350 or 700 watts of solar max, along with up to 1100 watts max on the 40 amp control panel. And there's a meter option with either one of these. It's not an add-on meter. You just have to get the right one at the time of ordering. And then the ProStar MPPT also has data logging and Ethernet capabilities to add that to a system as needed. The smaller Morningstar, SunSaver, and ProStar controllers have been used in the industry for the last nearly 20 years with wide range success. The small SunSavers are 6 to 20 amps and also offer lighting features as well. And the ProStar Generation 3, which were released earlier this year, are 15 or 30 amp, along with a choice of a meter as well. And that one now has more features along with lighting controls. Focos are just real simple. We spoke about those earlier. So, and the handy part about the small Ecos 10 and 20 amp versions are they're both 12 and 24 volt in the same controller to cut down the number of parts and also give more flexibility out in the field. And the Dingo is our option for 48 volt systems. The accessory panels are a plug-in or wire-in accessory that can be added to any of the PowerReady Express control panels. And they're a really handy way to increase the applications where the PowerReady Express system can be used to have a timer for timed loads, which are not lighting controls, array combining, DC to DC converters, or even a small inverter for small AC loads. So here in this photo, the PowerReady Express control panel is sitting on the rear of the enclosure. This is one of the, looks like an F2, white powder coated 2 battery enclosure. So controls, breakers in here, and then mounted on the studs on the side plate is a small 200 watt inverter to serve small AC loads. So that's a great way to increase the flexibility of the applications where the PowerReady Express can fit. The timer is simply that. It's a timed load. I know that I've done quite a few of these for small irrigation timers for small pumps and that sort of thing. But the applications are really wide and set that you can have many different programs to run a specific load, and it's typically where the timer built into the solar controllers is primarily for a lighting feature, and the load doesn't fit into that, so we can solve that in another way. We also have a 3-pole array combiner accessory control panel so that we can bring in 3 strings of panels into this, and then combine that, and then the leads that are shown at the bottom simply wire over into the standard input terminals for the solar controller. So it doesn't increase how much wattage you can put in because the controller is the limiting factor, but it's a really handy way to have a combiner box inside our enclosure without going to the hassle and time and expense of mounting an external one. And also, to gain a little bit of space in some of our pole-mounted enclosures, we have this really handy radio shelf, because it's named that way because some people put small radios on it. You can do that for any other or similar sized part. And that uses some of the empty space that is in front of the controllers and above the batteries. So it's a handy way to make the most out of the enclosure space without getting to a secondary external enclosure or upgrading to a larger one of our enclosures. So think of those questions, because we'll get to those here pretty soon. This is one of the 200 watt inverters, and those simply connect directly to the battery. So it's a great and easy way to do a 200 watt inverter in a very small system for small AC loads. And same one for the 24 volt system. It looks exactly the same, along with some specifications. So we just have to remember to size the system in to cover the efficiency of the inverter as well. And then there are 2 options for a DC to DC converter. One going from 24 volts down to 12, and one going from 12 up to 24 volts. And this will wire back over to the main control panel, and with the terminal blocks there, you still have the choice to wire a 24 volt system, 24 volt load to the control panel, along with a 12 volt load that would be wired to the load terminals that are located on the converter side panel. I hope that makes sense. And there's the other one, looks the same, and specifications. So we just have to build the system efficiency in to the system sizing, make sure everything is covered. And then we do have some 12 and 24 volt size guides that you can use. The just having a little difficulty here. So it's just, a map of the world showing the worst case solar data, and this is what we found, that quite a few folks run off the rails by using the wrong solar data, with the vast majority of the industry serving grid-tied applications. Average weather data and average solar data is perfectly fine to size a grid-tied system. However, when that is applied to an off-grid battery-based system that has to get through the dark and stormy Decembers, those systems will fail because the difference from average solar data to worst case December solar data in some applications can be half. So the systems that are sized based on average weather data, we see those fail in the fall when the sun starts going down. And this chart will show kind of what the maximum load is that one of the systems will support. And this is also pretty well generalized. So if you have an application and want to know what the solar data is for Kansas City, just simply give us a call and we can find that for you so that we can pick out the right system. But for the rough guess of the solar data if you're in a place that's pretty well specified. Find your monthly worst case peak sun hour or solar data. Find the rates column and then find and figure out what your load is, and then see which of the systems will cover that load for that location. So at this point, we're looking at an 80-watt system, so a single 80-watt panel, 12 volts, and a single 108 amp hour battery. Pretty common system. So you can actually, on one of the standard systems, you can actually look it up on our SunWize Connect website, search by the part number, and if you have your account set up, you just click and go and order it right there. So this is where the side panels come in as well. So if we account for the inefficiencies of the inverter and the DC to DC converter, we can size that in as well and pick out the right system along with the right accessory panel to cover those needs as well. And also there's a note there that mentioned that there's a basic system sizing webinar that's posted on our website as well, that you can learn more about the overall how to size a system. So, and the system design guide will also, cover the basics on array to load ratio, autonomy, or battery capacity. LOLP just means loss of load probability based on the solar array and the solar resource, and account for any losses there in the system. So, and that's applicable to standalone PV systems. So we do have up on our website, one of the banners will show a link over to one of the live stream systems. That is a camera showing the system, and also it's also connected to show off the system performance based on some of the Morningstar controllers that have live Ethernet capability as well for those customers that really just demand lots and lots of data. And also other past webinars on remote communications and how to use the controllers to communicate out with. Tech notes are available that stretch way back in time, along with the full list of other webinars that we've done in engineering bulletins. So we've got a lot of resources here, including our people. So feel free to reach out to your guy and ask questions, and we're happy to help. So see if we have any questions. See if Errol will pop in here with any questions. And other than that, it's time to throw out some questions. One question that I see is, what battery chemistry gives the most dense power storage?
Hey, we do have a couple of questions here.
Okay. Yeah. Why don't you go over those?
One question from Peter Martin on general costs for one of the larger size Power Ready Express systems, either 12 volts or 24 volts.
Okay. Let's see if I can. I wasn't prepared for that one, but what's the next question? I'll look up the other one.
So another question is regarding a handout on this presentation, and I can address that. Peter, we probably will actually do a PDF on this presentation, but it probably won't be for a couple weeks after we post the webinar. So for right now, it's probably going to be a webinar-only format. All right, we have one more question from Stephen Shepard on best battery for high altitude and cold climates. David, I'll also let you chime in on that. I'm sure you have a take on it. We've done some analysis based on the specs for the D-rate curves for most of the major batteries that we carry. And I will say that in general, they're all the top of the line brands, MK Deca, Concord, Rolls. They all are very much closely in line with each other. There's not one that deviates significantly from the others. But in terms of the raw numbers, I do believe the Concords state some pretty exceptional D rates on the cold end.
Yeah, and in general, it's also battery chemistry of AGM, or the absorbed glass mat, go down a little bit more in temperature than the gel. That's my understanding, and that's generally how I like to use those. But the gel rating still goes down to minus quite a bit, something that you don't want to be outside in anyway. So,
Stephen, one thing I'll mention that we kind of learned as we were going through this in more detail is that really it's dependent on the electrolyte freezing. And so the electrolyte will freeze in the battery more easily the more that the battery is discharged. So what that means is that if you have a fully charged AGM battery, then it can withstand the electrolyte freezing relatively robustly down to about -40 degrees C. Once it starts to get more than half of the energy discharged from the battery, it starts to become more and more susceptible to freezing. So one of the ways that you can combat battery freezing actually is to simply oversize your batteries so that they never reach a depth of discharge such that it would cause the electrolyte to freeze. And you can find all that information in any of the battery technical manuals on what the electrolyte freezing point is for each battery.
right, and along those lines, even into other batteries not really suitable for this, but a flooded lead acid, you lift the cap on and look down into the electrolyte mix. That has a freezing temperature if it's discharged somewhere in 15 to 20 degrees. So the state of charge on a battery really affects the freezing temperature dramatically. So keep it charged. I've had customers that have seasonal systems, and oh, by the way, the last guy out flipped the breaker and turned the solar off for the winter, and it wasn't a surprise that the batteries were frozen and cracked the cases. So it's if you turn off all the loads and just leave the solar to top it off, then you'll be in good shape for the next season. So I did take a look at the wholesale price on one of the systems at about 560 watts is about $5,600. And the other one, I was looking for the recent quote. I also quoted out a 945 watt system, so definitely on the higher side. And I can't find that right now, but I do remember the comparison of a Power Ready versus Power Ready Express. On the wholesale, it was about $1,000 less for the Power Ready Express. So since we just keep it out of the production in the engineering queue. But definitely give me a call with any questions. Do we have any other questions?
Not yet. I think we'll give folks a couple more minutes to get anything else that may be on their minds. Looks like we got a question on warranties.
Okay. System warranty is a year for workmanship, and then along with that is the product warranties for solar panels of power production for 20 or 25 years, whatever those are, plus controller warranties, which are typically in the 3 to 5 year range.
I got a question on the robustness between various battery chemistries. I assume they're talking primarily about both gel and AGM for VRLA batteries, as well as probably some of the more advanced battery chemistries, lithium iron phosphate, nickel cadmium, and a couple other ones.
Right.
David, I'll let you speak to that as well, and then I'll also chime in, I guess.
Yeah, and the Power Rate Express that we're talking about today is really built around lead acid of gel or AGM. Robustness can mean a couple things to a couple different people, but one of them is just cycle life of just how many cycles will you get out of the battery before it's worn out. And in general, the gel batteries serve up a much longer gel cycle life than AGM style. And in many cases, the gel are less expensive than the AGM counterparts. So that's why I tend to go with the gel, unless we get back into the other situation where it's a super cold climate, and then at that point, I recommend the AGM. The other more advanced styles of batteries might be better served by Arrow, because it's not really, at this point, applicable to the Power Rate Express. It may be as the lithium will, when and if the lithium industry grows up and is compatible for small systems.
Yeah, I'll agree with the advanced battery chemistries. I think the number of applications that they are cost competitive right now with VRLA batteries, all things considered, is very few. I recently did a cost exercise with a leading advanced chemistry manufacturer, and they basically admitted as much, that the cost economics weren't in their favor given how relatively cheap VRLA batteries are. There's a couple exceptions if you need particularly high power output capabilities or particularly fast recharging capabilities. That's one exceptional case. Also, if you have outrageous servicing costs to replace the batteries at a site, it may be most cost economical over a 15-year project life to install a set of batteries at the get-go that will last that entire duration. Outside of those particular cases, maybe a couple other small ones, in the most part, replacing high-quality solar VRLA batteries in 5 to 7 year increments is going to be your best bet. In terms of robustness, Rob Rollo, our senior engineer, and I have released a couple tech notes on this. Basically, our sort of conclusion was that it's more dependent on the specific battery and the battery manufacturer than it is about the chemistry. You can find cases in either chemistry for a superior battery depending on the manufacturer themselves. We do have another question on controller aging and proactive replacement rather than waiting for a failure. That's a really good question. I have not heard that come up before. David, I'll let you chime in. Also, I would mention that we'd be more than happy to reach out to both Morningstar and Focus and get their take on that directly as well and pass that along.
Yeah, I had this come up with some folks that just want to do, like I said, doing the proactive stuff. External forces otherwise ignored, such as lightning, since lightning always wins. The service life, we really see a lot of systems at 10 years, and that's kind of where I would put the proactive replacement cost or replacement time at, is if you got something at 10 years, you may as well start looking at swapping out a controller, because they're generally a fairly inexpensive way to do it. And at that point, it's if you haven't done it already, it's definitely time to look at your batteries as well. Anything to add to that one, Errol?
Since I don't have a ton of direct experience with it, I would just defer back to the manufacturers and get what their direct take is. We've got great relationships with both. It's for us to reach out, so I'm just going to defer on that one.
Okay.
We do have a couple other questions here. Let's see. Okay, so we got another question on heat buildup. in particularly hot climates. This is obviously a big question to prolong the overall life of the batteries, since the general rule, I believe, is that for every 10 degrees Celsius above ambient conditions, in prolonged 10 degrees Celsius above ambient conditions, it will reduce the life of your battery by 50%. So if you are at sustained temperatures of 20 C above ambient, then your batteries will last approximately 25% of time as they would. So obviously it's a major issue for high heat and batteries. One of the major ways that people address this, there's a couple major ones. One is obviously active cooling with an AC unit. I have experience doing that in enclosures. They often have them integrated into the enclosure themselves. Not a great option oftentimes for off-grid applications since it consumes so much power. There is insulation that can be used on the enclosures, foam built in, but primarily for high heat, I think the solution that I've heard usually works the best is burying them underground enough so that you can use the sort of heat sink reservoir of the earth to keep the temperatures consistent and cool.
Right, and then the other approach is also just using the white powder coated enclosures, because those do make a big difference over bare aluminum. And along with the fact that you have a lot of mass with the batteries, and the battery temperature will track a little bit higher than average ambient throughout the day, because it takes a while to heat up and it takes a while to cool down. So those really you won't instantly get the battery bank all the way to super hot, just because it takes time for that to heat up and cool down.
We did have another great question that I answered, but I wanted to double check with you, David, regarding off-gassing of VRLA batteries. My understanding is that that VRLA batteries, even the quote-unquote sealed ones, aren't actually truly sealed, and there is some amount of off-gassing, hence the valve regulated. David, my understanding is that is completely benign, and that you can have that in office environments or anywhere else, and it's not going to affect air quality or anything else.
Yeah, I mean, it takes quite a bit of hydrogen to get to the point, and that is the main reason that we use NEMA 3R vented enclosures, as opposed to NEMA 4X completely sealed ones. Is exactly that reason.
So to answer Matthew's question directly, there will be a small amount of hydrogen gas, and depending on how many batteries you have and the overall ventilation of where you're going, that could potentially be of some concern, but in the vast majority of cases, I think it'll just be inert hydrogen gas that dissipates and disperses far, far before it can get any sort of concentrations that would be of concern.
Especially because the systems that we're talking about have very few batteries in them. It's a lot bigger issue when you have a whole room full of batteries. But this is a few number of batteries with the sealed chemistry to start with, and also a vented enclosure.
Okay, well, we're closing in on a few minutes left till the end of the hour. We got one more. You said every 10 degrees ambient. Ambient temperature defined as this, I believe, is 77 degrees Fahrenheit.
Yeah.
25 degrees C. But I just wanted to have this modern thing. I was just going to have those sent out here since.
All right, well, if there are no further questions, then thank you guys for the very interesting questions. That was good. Oh, we've got a couple more coming through. Question about off-gassing would be for a large hull structure systems. I mean, I would say that as long as you're aware of the issue and you account for proper ventilation, as long as there's some significant airflow through the structure, I would not think that would be an issue. And of course, we can consult with the manufacturers directly to get their take on it. I have no doubt MK has installed lots of sealed VRLA batteries in an environment such that they've at least had to take that into consideration.
I'm sure they are. They're the ones who use.
Oh.
Said it was here too. Hello?
So,
What's up?
you got another live one there, Errol?
No, it's just typing in the battery.
Okay.
Kept getting a couple more at the end,
Well,
but I think that's about it.
We don't have to
Yes,
pay for it.
definitely. Thank you, everyone, for joining us on this, and reach out and ask us questions directly here on this last slide. I'm David Love, the guy at the top, but you can reach out to any one of us here, and we'll be happy to help you. I really appreciate the bunch of questions because it makes it a lot more fun for us, and definitely give us a call as you need to. Thank you.
Thank you, everybody. Again, this will be posted on the webinar section of our website.
You know,